Hello everyone, welcome again to our discussion about the AI engineering book by Chip. Today we're gonna cover the chapter 8, Dataset Engineering, which for me is a topic super underrated by companies because with the democratization of the AI, like many companies think that it's very instant to get outcome from AI, but they don't want to discuss or like don't really want to bother with the how the data will be presented to the model, or in case that you need to fine tune and need to turn that pre-trained model into something specific for your use case. So here in our role as a machine learning engineer, data science, or AI engineer, any of these stuffs, we need to make sure that they comprehend these important of thinking of the quality of the data. So yeah, in the beginning of this chapter, um, she presents the importance of data curation, which is basically um, ask some questions and understand how this data will be presented to the model. So what data do you need for your application? How much? What is how do you define the quality? How do you evaluate if that data is enough and align it with your purpose? It's basically understand how the model will learn through this resource, and if this how this will be available for them to learn. And it highlights the importance of, for different purpose application, we require different data curation. So for example, for a single turn conversation, it will be a different approach for a multi-turning, which will require like building scenarios of multi-turn conversation, so you can like fine-tune this type of application. So talking about data quality, there's some important dimensions mentioned in this section. First is relevant. So the training example must be appropriate for the specific task that will be performed, considering contextual factors and temporal, and alignment with the task requirements. So in the annotation process, the annotation process should match what the task really needs in terms of factual accuracy, creativity, personalization, conciseness, and justification if needed. Um, Consistent, because we need to provide example for different real world scenarios that the application will interact with, so we understand that we are covering these cases. Format, so we need to provide these examples in the expected format that the application will perceive in the real world. um, Uniqueness, this is a very important. So um, given that we are working with like a non-deterministic application, we need to, in the training samples, we need to define what is the difference of each scenario, each use case, so the model can comprehend this easily. So we diminish the problem of ambiguity in the inference, in step. And also, final but not least, like compliant. All the data should not include like PII data and other like restriction that guardrails that we need to to include in our application. Um, Also, this this chapter talks about some really cool stuff, but they are covering this in these dimensions that I previously mentioned. Uh, Basically, she talks about the data coverage, the importance of covering in the training examples for the different use case that the model will interact with, data quantity. So defining in a more scientific way how is enough data to your model to learn, because basically with few samples, we have like some difference of how the model will perform, but with enough data, basically we have some benchmarks that says that some set of models will perform very similarly. So we just need to understand how it will be the threshold for your use case. And she also talks about the data acquisition and annotation process, presenting a pipeline on how to do with this in the in a more practical term. So the first step is find data sets, identify data sets like publicly that they're publicly available, filter low quality instruction, filter low quality responses, manually write some real some instructions, some responses, address the data gaps that we will see in this public data, and also add synthetic data to have the final data set. And note that this is like a many dimensions, so it's not like a single solution for all the case. You need to refine with different stuff. So that's pretty cool way to propose this acquisition and annotation process. Also, this chapter talks about the data augmentation, but I will not go in much details because this is it's not super specific for the AI engineering. Like for machine learning, this is a topic that is being covered from the past years, so nothing here new here. But what is important here is that the motivation, because basically there is this notion of model collapse, because training AI applications required using a real world data, and basically these models are getting bigger and needing more data. So consequently, even it will have we'll reach some time that we will not have like much more real data word to present to the model. So we need to provide synthetic. So that's is the main motivation. Finally, talking about model distillation, which is a technique to train small models based on larger models. So we have this process of calling the smaller model student, and we have the teacher, and the goal is to make the student like mimic as much as possible the behavior of this larger model, so we can have a lightweight model deployed to production. um, Finally, talking about data processing, it's like a thing that varies for all use case, but we have central steps that is covered for all type of application. First is data inspection, so we need to take a look in your data and ask some questions. So where does data come from, how it is being processed, how it will be the best way to process this, what else has been used for, and what is their purpose. Provide a data deduplication layer, so we will not fed bad the duplicated data to the training process. Cleaning and filtering, and finally data formatting. So we provide a high quality data to the model in the training phase. But yeah, overall that's it from this chapter. Next chapter we'll cover the inference optimization. Yeah, I think that's it. See you in the next lesson. Bye bye.